We're at the point now where we're going to need to be able to deal with factoring, at least the basics of it. So let's talk about that. First of all, factoring is often confused with simplifying. What's the difference between them? Well, simplifying means to perform all possible operations. In other words, addition, subtraction, multiplication, or division. Once you've performed all of those that can be performed, you have simplified whatever you're working with. Factoring, on the other hand, means to take something and to write it as a product. In other words, to write it as a multiplication problem. So, for example, a problem that says simplify 2 times 3 is telling you to do that multiplication in there and write the answer as 6. On the other hand, a problem that says factor 6 is telling you to take the 6 and turn it into a multiplication problem. So you would answer 2 times 3. So we have two ways of writing the number 6. We can write it in simplified form, where you just see the 6, or we can write it in factored form, where you see it as a multiplication problem. That's the difference between factoring and simplifying. Now, to help us in our factoring journey, we're going to need something called the distributive property. When you're first introduced to the distributive property, it's introduced as a way of multiplying. Let me give you an example. Suppose a problem says simplify 2 times 3 plus 4. Inside the parentheses, 3 plus 4 is 7. And I'm working inside the parentheses first because of, please excuse my dear Aunt Sally. That's that little memory aid that tells you when you're simplifying what order to do the operations in. So the MD is telling you to do multiplications and divisions before you do additions and subtractions. However, and exponents come before either of those. However, anything in parentheses gets done first. So that's why, even though addition is close to the end of the list, I did that before I did the multiplication by 2. Why? Because the addition was in parentheses. Okay, so we have 2 times 7, and that gives us 14. Now, the distributive property says that if you have a number A times the sum of two numbers, B plus C, another way to do that is to distribute the A into the parentheses. So you'll often see people write something like that. In other words, we can compute this by doing A times B plus A times C. So let's apply that to the problem we just did. The distributive property says that that problem we just did, 2 times 3 plus 4, could have been done by going 2 times 3 plus 2 times 4. In other words, by distributing the 2 into the parentheses. Let's see if we get the same answer, because if we don't, then we don't want to be using this distributive property. 2 times 3 is 6. 2 times 4 is 8. And yep, sure enough, 6 plus 8 is 14. And yes, we can always use the distributive property. Now, honestly, I personally would not use it for this problem because you don't have to use it. We've got this other simpler way of doing the problem. And if you use the distributive property on something like this, because it's more complicated, it's just easier to make mistakes. So then why are we even talking about this distributive property? Well, let's look at the next example. Simplify 2 times x plus 4. Here we run into a problem because I don't know what number x is. It could be standing in for any number. So that means I cannot perform the addition in the parentheses. I can't do x plus 4 because I don't know what x is. So am I just stuck? Well, no, the distributive property gives us a way around that. It says, well, just distribute the 2 into the parentheses. That gives you 2x plus 2 times 4, so 2x plus 8. And there you go. Now, what about the problem factor 2x plus 8? Remember, factor means to take something and to write it as a multiplication problem. So in this case, we would say, oh, this was the answer to the multiplication problem, 2 times x plus 4. Again, we have two ways of writing this expression, 2x plus 8 and 2 times x plus 4. They're equal to each other. They're just two ways of writing the same thing. One way is simplified, the other way is factored. You might be wondering, why don't we just always simplify? Why are we bothering with this factoring business? And the reason is there's things you can do when expressions are factored that you cannot do when they're not. You might remember, for example, having seen solving equations in the past where you had to factor before you could solve the equation. Okay, this thing we did right here where we factored out the 2, that's what you call it when you pull the 2 out front using the distributive property. So this problem where we factored out the 2, that's called factoring out the greatest common factor, which is what we want to talk about next.